Hey guys, let's talk about exploring Helm and Kubernetes scale up and down. Now, as your application is being assessed by more users, you have to scale up your app so that it can be in position to handle the increased load. Also, when there is a load demand, you should also scale on your application so as to make sure that the usage of resource is optimized. So Kubernetes provide us with kubectl scale command, as you can see on the screen, which can help you to scale up or down the number of pods which are made available in deployment. Now run the following command so as to know the number of pods which are running in each service. The command is hem status by app. You will notice that each pod has a running instance. At this point, you can scale up your node.js app so that it can include 3 copies. You only have to run the following command. And the command is, I'm quickly, the command is at the top of my screen as I'm pointing through my cursor. You can now check for the status so as to ensure that you have only 3 parts. That is how scaling up can be done. We can now demonstrate how scaling down can be done. Just run the following command so as to scale down to 2 parts, as you can see here. Now you can then check for the status so as to be sure that you are now running 2 nodes. Now let's quickly move how to balance traffic between pods. It becomes easy for one to spin up 2 replicas which belong to a similar pod during the deployment of an app in the Kubernetes cluster running cloud. You will be provided with the option of creating a cloud network load balancer which will serve to direct traffic between the pods. This is a simple example of Kubernetes service. You are now aware of how to get your Kubernetes load balancer working during the deployment with Helm to GKE. The command made use of the service type option so as to create an external load balancer as demonstrated below in this load balancer command. So after invoking it this way, rather than the creation of the external load balancer, Kubernetes will take the responsibility of configuring a load balancer with the internal IP address of the pod, set up firewalls, and do other tasks. Now, if you need to have a view of the service of your load balancer service, just run the command given below, which is this kubectl describe as my app. Take a note of the load balancer ingress field that specify IP address of your load balancer and endpoint field that specify internal IP addresses of 3 node.js ports which is in use. Also, the port field defines the port which the load balancer will have to listen for the connection, while the node port field defines the port of an internal cluster node which the pod will be using so as to expose the service. Once you run this, note that it will not run in a similar way as Minikube, which is being used locally. You can look at your Minikube deployment and you will notice that the service type option has been set to node port. This will expose the service of specific port on each node found in the cluster. As you can see this, you can now have a look at the details of the service. So as to verify this, just run the command, this command. In this case, the difference comes in that instead of creating a load balancing service, Kubernetes will create a service which will listen to the incoming request and it will then direct it to open a static port on every endpoint. Okay, so now let's discuss a bit more about rolling update and rollbacks. Now, the rolling updates as well as rollbacks are among the advantages we enjoy when using Kubernetes cluster. While the rolling update, it is possible for the development team to perform zero downtime upgrade, and this is very important when it comes to production environment. Kubernetes also support rollbacks which will help one revert to the previous state without necessarily having to stop provision of service to the users. You can easily upgrade your system by running the following command, this command. hem upgrade my app, and you can then use the hem history command so as to check the status of the upgrade. This is shown below. You will see that your app has been upgraded. It is easy for you to perform rollbacks in Kubernetes with hem. You just have to use hem rollback command and then pass the version of the app you want to roll back so as the parameter. This is given below. Now, in the above command, we are rolling back to the version of the app to version 1. You should be aware of some of the features which will Kubernetes offer, including scaling as well automatic load balancing. So in a nutshell, to summarize this chapter, we learned various functionalities and various commands on how to proceed um, in the same. So in the next lecture we would be discussing some different topics which are still left over. So till then, thank you very much. I'm taking a pause. Thanks.